Hey guys, in this video we're going to be talking about solving equations with variables on both sides. And we're also going to be talking about writing equations and solving them involving distribution. And that's where we start for this lesson. So DeAndre's ordering 3 tickets to a concert. Each ticket that he purchases does cost the same amount, and they each also have a service fee of $4.75. If his total bill was $111.75, how much did each ticket cost? All right, so A says define your variable. So the first thing we're going to do is state what letter we're going to use for our variable. I'm going to choose X, and what it represents. And remember, that's always whatever our unknown is, which in this case is how much each ticket costs. So X is the cost per ticket. Okay, then part B says write an equation that represents this situation. All right, so we need to know all of the important parts here in order to do this. So let's underline those. First of all, we know that it's 3 tickets. That's important. And then we also know that each ticket costs the same and also has a service fee of $4.75. So that means for each ticket that he purchases, it's the cost of the ticket plus $4.75. Now we know that he's purchasing 3 of these, and each of them has that service fee, so we have to multiply the sum of that by 3. We also know his total bill was $111.75, so we're going to set that equal to $111.75. All right, part C says solve your equation, and is it reasonable? All right, so when I go to solve, the first thing I'm going to do is distribute this 3. 3 times my x is 3x. 3 times 475, let's get a calculator. 3 times 475 is 1425 equals 111.75. All right, so remember, each ticket has a price, and each ticket has a service fee. So that's why we have to have 3x and multiply the 475 by 3. All right, so if I want to go solve this, I'm going to first subtract the constant, which is 1425. That's going to leave me with 3x equals, and then I'm going to take 111.75, and I'm going to subtract 1425, and I'm going to get 97.50. The final step is divide by 3. So for part C, I get x equals $32.50. Now don't forget to put a label on that. All right, and then finally part D says graph your solution on a number line. So remember, all that means is create an accurate number line. Got to have at least 3 numbers. I like to put the solution in the middle. And then I'm just going to put 32 over here and 33 over here. But you can choose 2 numbers to go on either side as long as they're equidistant from the center. And then I'm just going to put a point where my solution is. All right, that's it for this one. Let's try the next one. All right, this one is our first one with variables on both sides. It says Rory planted 2 trees in her yard. One tree is currently 38 inches tall and grows 4 inches per year. The second tree is currently 45.5 inches tall, but only grows 2.5 inches per year. How long will it take for both trees to have the same height? All right, once again, let's define our variable. So I'm going to use x again, and our unknown is how long it will take for both trees to be the same height. So how long is a measure of time. So we're going to say x is, and in this case we're dealing with years. So x is number of years. All right. So when I go to write my equation, which is part B, we're dealing with 2 trees here. So we're going to want to do 1 tree at a time, and we're going to set them equal to each other because we want to know when they're going to be equal. So let's start with tree 1. Tree 1 is 38 inches tall and grows 4 inches per year. So it started at 38 inches, and it adds 4 inches per year. That means times the number of years. I want to know, when is that equal to the other tree? Well, the other tree is 45.5 inches tall and grows 2.5 inches per year. Okay, so 45.5 is what it started at, and adds 2.5 inches per year, so times the number of years. All right, part C wants us to solve it. So when you have variables on both sides, your goal is to get the variables on one side of the equal sign and your constants on the other. It doesn't matter which way you do it, as long as all variables are on one side, constants are on the other. I personally like to have my variables on the left, so I'm going to take this 2.5x and I am going to subtract it over to the other side of my equal sign. Now, to make sure that I keep my equation balanced and I'm subtracting it in the correct place, you want to make sure that you line it up with its like term, which in this case is the 4x. All right, so this is going to be 0. I'm left with 38. And then 4 minus 2.5 is going to be 1.5. So plus 1.5x equals 45.5. Then I'm going to subtract this 38 over to the other side so that my constants are together. That's 0. I have 1.5x equals 45.5 minus 38 is 7.5. And the last thing I'm going to do to get x by itself is divide by the 1.5. So I get x equals 5. And remember, we want to know how long it takes, so that is years. So it'll be 5 years before the two trees are the same height. And then part D, so this was part C. Part D wants us to graph it on a number line. So I'm going to do 4, 5, 6, and then plot a point on 5. All right, one last problem to try. If I can get the papers to separate. All right, the picture to the right shows the results of the 2015 Nathan's Hot Dog Eating Contest. Suppose the two winners decide to compete against each other. To make the competition more interesting, Matt will not start eating until Mickey has eaten 20 hot dogs. Assume that both Matt and Mickey eat at a constant rate throughout the competition. Based on the number of hot dogs eaten in 10 minutes by Matt and Mickey, how many minutes after Matt starts eating will they have eaten the same amount of hot dogs? All right, so this problem has a lot going on. So let's break it down as best as we can. First, let's define our variable. What is our unknown? So it is how many minutes after Matt starts eating will they have eaten the same amount of hot dogs? So once again, I'm going to use x. You don't have to. But basically, x is number of minutes. So how long it takes before they have eaten the same amount. All right, now here comes the tricky part, writing the equation. So we're dealing with both Matt and Mickey. So let's start with Matt here. So we know that Matt has eaten 62 hot dogs in 10 minutes. In order to find out his rate of change, we need to find the unit rate here. So we're going to do 62 divided by 10, which means he eats 6.2 hot dogs per minute, which is kind of insane. Now let's talk about Mickey as well. She does 38 in 10 minutes, which means she can eat 3.8 hot dogs per minute, which is also insane. So those are the rates that we're going to be using on our equation. So when I come back to my equation, if I'm going to talk about Matt first, right? He eats 6.2 hot dogs per minute. So 6.2 times the number of minutes will represent how many hot dogs Matt has eaten. I want to know when he has eaten the same amount as Mickey, okay? So I'm going to set that equal to how many she eats per minute, which is 3.8, so 3.8x. But remember, I have to take into account that he's not going to start until she has eaten 20 hot dogs. So we're going to add 20 hot dogs to this equation because this represents Mickey. 3.8 per minute plus 20 before Matt even starts, okay? So that's our equation. Now let's go ahead and solve it. So again, I want to get the variables on the same side, which means I want to get them together. Let's go on the left because that's the only thing that's on the left side of the equal sign is a variable term. So I'm going to subtract 3.8x over to the left. So now I have 6.2 minus 3.8, which is 2.4. X equals 20. And then to finish off the equation, I'm going to divide both sides by 2.4. So I get x equals 1. Okay, that seems a little, let's see. That's not correct. That's not even close. So 20 divided by 2.4 is 8.3 repeating. Or if I want to use a fraction, this is the same as 8 1/3 minutes. Okay, so that's the answer to part C, how long it takes. All right, notice how when I did my answer initially, I realized that 1 minute didn't seem correct. So I went back and recalculated and noticed that I typed the wrong numbers in. That's something that you should be doing as well, okay? All right, now part D wants to know what the number line looks like. So I'm gonna put 8 1/3 here. And I will put, I don't know, let's just do 7 1/3. And then 9 1/3, just to make it easy. And then again, the point will go on 8 1/3, because that's how long it takes before they've eaten the same number of hot dogs. And that's it. That's how you solve equations with distribution and equations with variables on both sides.